Hey, what's going on, guys? Good, Mikey Kings here. Like, I believe that the further I go within this Bitboard CHESS Engine development, the more it starts look like not I'm teaching somebody chess programming, but I'm actually getting taught chess programming by the community members, and the help that I'm getting from you guys is just incredible, and I'm so happy to get that help. Basically, I could never ever believe that I will learn so much by starting this tutorial. Like, I was just there was an intent to share my experience, but eventually it happened that you actually started teaching me chess programming for free. This is so cool. I mean, I'm so excited about this. So like, starting from this video, probably yet another credit to Pedro Castro and to Harold, can't pronounce his last name, sorry for this, for pointing out the bugs, for giving me lots of consultations and things like that. So I was going to make a video on scoring, on mate scoring within the transposition table, but it turned out that there are quite a few bugs occurring within the search that we definitely need to deal with. But when we will do this, the performance will grow, and I really love the results I'm getting now. I'm starting getting out, to be honest. And another credit to give to Sven Scholl, I guess his name. Sven Scholl. I'm not sure if I'm pronouncing this correctly, but when I asked for when I asked the question, please explain as if you were explaining to idiot, and that's the exact case, because oh my god, this is really so hard to understand some things. I'm just getting stuck from time to time completely. And here is one not that bad reply by Ras, and I said, like, yeah, this is fine, but it's not good enough for idiots, unfortunately. And then Sven with his smiley here, he said, like, okay man, so you want to read, so here you are. And he writes, OMG, so many explanations that regards to my implementation, to my code, to my examples in particular, and I'm rereading this post again and again and keep learning from this. So like, I thought that I would explain how to deal with the mate scoring, but I'll just I'll just implement that using the hints from the community members. And maybe, I don't know, in 10 years, in 20 years, in 50 years, I don't know when this would happen, I would then actually try to explain how it works. Because, like, when you don't know anything, you feel like, okay, I'm gonna explain you things, guys, like how it works. And then you start, like, the knowledge, like, pushing you down, and you realize, like, okay, now I know something, but oh my god, how am I supposed to explain that? Oh no. So that's how I feel today, guys. And I thought just to put a link, but this link is somewhere in the commentaries, so please make sure to read the commentaries by these guys, by Pedro and Harold. I'm really wondering the age of them, by the way. So YouTube statistics says that my subscribers are 55 years old and older. So I guess the age of these guys is really solid. So the, like, senior age there. I'm not sure, but I really feel so. So I'm sorry if I just I'm full with respect to you guys, and when I'm calling guys, I'm not mean like I'm at the same level with you. I feel like you just somewhere up there and I'm somewhere down there, and I'm very respectful to you guys. So just English is not my native language, so if I express myself somehow in not polite way, I'm sorry for that. Really, I really respect you and your help, and I really appreciate you guys. Well, anyway, so yeah, regarding this post, I loved it so much, so I stored this as a text file, and I would append this text file with a version of code that would be regarding to mating scores, because this is incredibly useful and valuable information here that I would never say better than how it's said here. So Sven rules really. So this is so cool post. Okay, guys. So this is it regarding the credits, and now let's get back to work. So here I've drafted a list of what we need to do, what we need to fix. So without further ado, let's actually go for it. So the very first nasty thing occurring here is I forgot to track bugs within the null move search. So let me just have a look where we are now. Okay, so this maiden position, well, let's actually try to compile and run the code and then go for some adjustments. So make well, probably, I would even probably like to go for starting position here, because it's more like better way of doing things. So parse fen, and because we don't yet deal with the maiden score, so just want to keep it like this. So parse fen and start position. Okay, and now let's make debug and run the code. Okay, and then we go for fixing things. Okay, but not in the release mode, but in the debug mode, please. Okay. Depth 10, where are you calculating more? Okay, let's drop it at depth 10. I don't really want that more at the moment, at least. Okay, good. So first thing to consider, track plies, increment plies in null move running. So let's go to the null move running, and here I want to increment plies. So ply increment, not plies, ply plus plus, and here after the take back I want to decrement ply. So well, actually, well, it seems like I've been doing this well, it doesn't matter that much before or after take back. Yeah, but I did this before. Okay. Oh my god, so many take backs. Okay, it takes too long, so let's drop back to null move. Yeah, and decrement ply here. So ply minus minus. Okay. So done. Get done with the first. So this is done. Okay, the next thing. Even though when I was testing this ply depth overflow in the questions, even when it was a depth of 30 plies, even in that case, there wasn't really any overflows. But again, just for extra safety reasons, we'll add this overflow tracking as well. So if we have a look, okay, my kids are going crazy again. Oh, she just woke up. Okay, so she's just cleaning herself. Okay, so this part. So if we're to dip, then just return evaluate, and well, I'm not really sure where exactly we need to do this. Well, let's make it, I don't know where exactly this has to be done, to be honest. Well, let's make it here. So just compile and run. This won't affect anything really, so the number of nodes should be the same. So 8, 5, 6, 3, 4, 4. What? Hey, you kidding me? Hold on a sec. hold on a sec. What has just happened? Hold on a sec. This is impossible. Did I just see the wrong place, or so why did the nodes? I did check this stuff, so how can it occur actually? Does it really occur in here? Or hold on a sec. No, it doesn't. It's not. It doesn't regard this part. We're not getting here. That's because of the plies. And even though the number of nodes is getting bigger, still this is fine. This is normal. We'll reduce them later on. So yeah. So this was increased when we added those plies. Yeah. Within the null mode. So well, that's actually, so as far as this doesn't do much, let me just want to check this theory. So if I just remove them back, this is the weird stuff we shouldn't do, most likely leading to the bugs. So it's just it's seemingly we're saving the nodes, yeah, but actually we need to deal with this splice. And this should be here, but don't get confused by the number of nodes getting increased. It's more likely this number is wrong rather than this one is too big. So okay, we just leave it as is here. Okay, let's move on. So we're done with this quiescence. Save. Okay, and another really cool thing. Find a better place for the beta cutoff. So quite often, well, literally in all the open source chess engines I have ever seen, I saw that this kind of stuff that regards to the beta cutoff is usually taken, usually happens here, and I didn't understand why this is needed. Well, actually here in question search, as far as we don't really do much here, it most likely won't affect the search, but let's see. But in our main Nigamax search, it would dramatically increase the performance. Yeah, it doesn't do anything here, but I just want to keep the same structure. But it will do the same within our Nigamax search. The node savings would be dramatic, because before making this beta cutoff, first what we actually do, we enabling this flag, so the exact score would get stored in the transposition table, and we're writing the principal variation. So that's the way how to improve our move ordering in simple words. So if we just improve our alpha first and then make this beta cutoff, then you just have a look what will happen now. And again, like, just to give you an idea that this principal variation would be the same, so just copy this, and well, let me, so this was the initial version, and you see how dramatically the number of nodes would get reduced now. So this is really dramatic. You see, like, we had 1 million and now we're back to 700s. So I think this is quite pretty significant result, which is a good idea to consider here. Okay, so this is another improvement we need to do, but it goes even more. So yeah, by the way, the principal variation, just to give you an idea, so was it G8? hold on a sec. It has changed. Okay, so this is a bit confusing. The principal variation actually has changed. So it starts with the knight to c3, knight f6, d2, d4, d7, d5. Well, it's a bit different scenario here. So, okay, just hold on a sec, guys. I'm wondering. Let's make it a bit deeper. Is it going to drop back to? Is it really going to drop back to e2, e4? Well, let's wait until the search is working. Well, anyway, replacing beta cutoff is a good idea, so I will definitely consider it. And this is needed for a better usage of the transposition table. I will show you this just right in a moment. Okay. Okay, so he now finds e2, e4, or even e2, e4, e7, e6. Well, this is interesting. Okay, guys, so I'm sorry, I feel a bit confused because it's not exactly the same. Oh, that's because here. Okay, that's because here I didn't. This is the source code for the version I've been working with, but in this version I did check this. I didn't only make this hash key, and did hash the site and not the in passant. So see, like, in passant is not getting hashed here, and probably that's the reason for why I'm having this results like this. That should be the reason. So yeah, okay, it would be a good idea to run this actually. So let's drop it to here. By the way, it works even like this, but yeah, it's not the best ever. So open terminal. I just want to make a little test, so you just enjoy the show and you don't need to do anything now. So make debug, and so is this still depth 10? So I'm just wondering, is this gonna be the same variation? Okay, now this is really getting confusing. Okay. Yeah, this is the version. So okay, so this is the PV, and it has less nodes. Yeah, but yeah, again, like so, because we just don't do this in passant stuff, and if I say if in passant, sorry guys, I should have done this before recording the video, but it's too late now, so it's not equal to no square hash key. So this is kind of like CodeMonkey's laboratory. Hash key within passant keys and in passant square. Yeah, even though it works better without this, but it just it might lead to some horrible bugs eventually. Okay, yeah, now it more like it seems that okay, so this is the principal variation after I fixed the bug of not hashing the in passant in my working version. So this is my current one. So E2, man, this is still not the same. Why it's not still the same? Okay guys, just sorry, I just need to pause the video to see why is this happening, because yeah, just to avoid producing even more bugs. So sorry for this, just hold on a sec, I'll be back in a moment. Okay guys, hopefully I've managed to synchronize the results, so now the principal variations are the same, and yeah, principal variations are the same, everything seems to be working. So what I did in order to do this, so this is another improvement, so just needed to be more patient basically. So another bug fix, so here it is. So another bug fix, read transposition table only when we are not in the only the ply is at least equal to 1, so not reading the transposition table in the root ply. This serves two purposes at least. Well, first, it improves the move order in itself, as we've just seen this, so the number of nodes has been reduced from 1 million to this 7,000 hundredths. And well, okay, just drop that. And another reason, which is even more important, in this case we don't really need to clear hash table every time, so it's another thing not to forget. So clear, don't clear hash every time. It's another bug to fix, not bug, another thing within the to-do list. So now I'll show you, now I will demonstrate the difference. So let's assume that we just make a movie here, and this would be the PV table and just what is sitting there, and then just search the position again. Well, the only thing, let's actually search the depth of 10 instead of 12 like this. And again, I just want to go to my Enigmatic search. So if I just read the hash straight ahead, in this case, okay, so null move, all moves. So in this case, see like what a disaster is gonna be happening. Oh, no disaster is gonna be happening because I didn't yet remove. Yeah, so now it's no disaster there. So no, yeah, let's make a disaster. So to make a disaster, we need to comment this out. So not clearing the hash table every time. And by the way, so now it seems like I'm not clearing hash table anywhere, which is not that great. It's probably why this probably a bit different. Well, anyway, the bad thing here is that we don't have a principal variation at all. So if this happens, we have this very last one, but if in the GUI we just stop calculating, say depth 7, we will have an illegal move because we have a number, a value of 0 in our principal variation. And that was what I've encountered in the previous video, and kindly asked you guys to help me, and Pedro Castro actually pointed this out, that in case if we retrieve the data from the transposition table at the root ply, this is the exact thing that is happening. We just overriding our not overriding, we just this is what's happening. Okay, so in order to avoid this weird behavior, well, by the way, before I forgot, so clear hash table should be placed in two places. So it should be placed to init all, so just clear hash hash table save. And also, like Harold told me to do, so where we have our UCI new game, here we want to initialize our hash table. So clear hash table and clear hash table like this. Okay, so before this we didn't really so this is the notes. When we ran this search, probably, well, I guess it wasn't initialized. Transposition table wasn't initialized, or was it? Well, anyway, now it is. Now it is. Yeah, it seems like the same number of nodes. Well, okay, doesn't matter really. So to fix this issue, just want to show you this another trick. So we go to our Nigamex search and add this condition. So only if ply and this score. So to make sure that we're not in the root ply, so at least ply is equal to 1. This is what it means. So in this case, if we're doing one search followed by another search, then in the other search we already can make use of the previous search, but at the same time we're having our root moves like this. So we actually didn't really search this stuff at all, which is really great. It speeds up the performance significantly. So just not doing this job, and we just searching this very last place, and again, like not fully, but just a few just a few, I don't know. Well, so that's the idea of what we want to achieve. So now we don't really need to clear the hash table every time we're making a new search, and this again, like significant, this speeds up the performance significantly and improves the play really nicely. Okay, so let's get rid of this redundant stuff here. Okay, and yeah, I just want to check my null move one more time. So okay, I'm hashing the passant, hashing the site, increment and deploy, decrement and deploy. Good. Okay, so what else do we have? So don't clear hash anytime, and I also did initialize hash table on UCI new game command from the GUI, and initially when the engine initially loads. Okay, so maiden scores would be the topic of the next. So I did replace the alpha beta the beta cutoffs. Okay, so yeah, clearing hash table. Okay guys, so now I just want to demonstrate you how this new updates would be working in the GUI. As far as we don't really yet have the maiden scores, there might be some issues with that, so it might I basically I didn't even test this without the maiden scores yet, so we'll see. Well, most likely it can play some weird moves in the end game or when it comes to maiden, so that would be the topic of the next video already. But what I want to show you now is actually it would be using the transposition table along the entire game and not doing the search from scratch every time. Okay, so let's run arena. Let's run our arena. And I just want to update the executable for an engine. So BBC YouTube. Well, it's the get rid of TCP for a while. So I just want to adjust this to chess programming and transposition table search fix 2. This one. Okay, and now look here where the principal variation occurring. So what's current? What is the current level? I'm just wondering. It's probably okay. 1 minute. Okay, that's just fine. So bullet game, not that bad. And you see, like sometimes we don't really have this principal variation been printed, and that means that we are actually referencing our transposition table and saving really lots of time. So you see, like it plays at the depth of 10, but it's really fast now because of the correct usage of the transposition table. So it's really fast now. So this is kind of, I just want to see a couple more moves just to get an idea. Like, well, most likely Arena would stop the game itself, which is really weird. But I'm just wondering. Okay, this was a strange move a little bit. Oh no, it's not strange at all. Oh, it just wins the bishop. Whoa, cool. But why doesn't it? No, this is oh, what a game. Yeah, probably I don't see something here. Probably I just don't see something. Okay, white is crushing black. So we have, oh, now even equal on material. I'm not really sure, was this actually fine or not? Yeah, interesting game. Yeah, okay. So by the time when it's playing, I'm just wondering, yeah, probably regarding coding, this would be it for this part at least. And as far as it doesn't yet support the threefold repetitions, it can just get into that repetition, unfortunately. But anyway, so it's really not that much time, but you see the depth is increasing in the endgame. Yeah, most likely. No, he doesn't fall into repetition even still. Cool. Okay, so is he gonna mate with the rook? Well, I think that Arena would stop this game. Or he just, yeah, so this is it. So you see, like, he can mate and making some weird moves. That's because we don't have the mating scores yet. So you saw, like, he just was moving the rook, so didn't really see those mating scores, which we need to adjust. So without those mating scores, it just may make some weird moves. I just want to have a quick look at the game again. I have some questions, like he was dropping the pieces, so until this time it's fine. Just a bit strange why I didn't just capture the bishop at the moment. Well, actually bishop is not going anywhere, so this is kind of fine. And here, and what if he takes? And probably check. Yeah, probably it's just better to do like this, really. Okay, takes. Now this is a bit strange, so okay, so he just takes this rook back. Okay, yeah, so it's quite pretty reasonable. Okay, so I'm pretty satisfied at this point. Okay, guys, so hopefully after the next video, when we will adjust our mating scores, well, hopefully it would be able to actually solve mates and find the mates in the end game. And if I don't find any other bugs, or maybe somebody would kindly point some bugs out again. In that case, most likely I will go for implementing this threefold repetitions, which I have no idea how exactly to do at this moment, at least. So I need to make some more research. I've done some, but I need some more. But anyway, the development process is going, so one day we'll definitely get the very first version. So a few words before I say goodbye and good night to you guys. Well, actually, I won't tell you good night because I'm gonna make one more video now. Yeah, so you know, like, transposition tables is really a huge topic that you can cover it in the 50 plus video series itself, and it really needs a deeper understanding of how it works compared to that I have actually. And I swear that when I will be ready to explain that, when I will kind of feel that I'm ready to explain, I will do that. So in the further future versions, there are really lots of improvements coming to this engine, but in order to do these improvements, so not just blindly grabbing some techniques from other engines, but based on some more solid understanding compared to what I have now. So only that would be the proper time, the right time to actually go for those improvements. So I just want to say that I need to grow a little bit more before that, and the very first version would be just a matter of kind of drafting this pieces of code that kind of just like a placeholders for the future techniques. So what I can say from my current experience is the matter of the strength of the chess engines is the matter of the details of your understanding. So the more details you understand, the deeper understanding of how it works you have, the more places for either potential bugs or improvements you see. So now I feel like I'm really blind because I don't even know sometimes like where to see, and some bugs might be occurring, or there might be lots of bugs right now in the code, and I have no idea even if they exist, because I don't even know where to look for them, where to search for them. So that's kind of it. Don't be upset about this, because still kind of plays chess, which is not bad at all itself, and everything I can do at this moment I will do, and then we'll just move on. So thanks for watching, guys. Your support is incredibly important to me, and like new credits every video, but to the same guys. So Harold, Pedro, thank you guys, thank you so much for supporting me. So hope to see you in the next videos. Until that time, take care.